This is Mars. Known as the Red Planet, this iron-rich, stagnant chunk of rock is dry and desolate. With an average surface temperature sitting around negative 63 degrees Celsius and an atmospheric density less than 1% that of Earth's, the Martian landscape is bare and unforgiving in almost every sense. But it didn't always used to be this way. We now know from recent discoveries that Mars once hosted not just liquid water, but an entire ocean, submerging much of the planet's surface. And, around 4 billion years ago, it's believed that the surface of Earth and Mars may not have looked much different at all. When microbial life was just beginning to flourish on the surface of Earth, the Martian landscape was likely covered with coastlines, rivers, and vast seas. But, at some point between then and now, the water disappeared. But why? How can a planet-scale body of water just vanish? And what caused such a tragedy? In the words of Carl Sagan, Mars has become a kind of mythic arena onto which we have projected our earthly hopes and fears. This raises a question to be answered in this video. If this can happen to our cosmic sibling, can it happen to us? But before we talk about how an ocean disappears, we have to discuss how it got there in the first place. Let's go back, 4.6 billion years back. At this time, the solar system as we know it was little more than a cloud of dust. Over millions of years, gravity slowly pulled this dust together until it reached a critical point. Temperature and pressure increased exponentially in the center until eventually fusion began. Our sun was born. Soon after, leftover material began to orbit around the sun. This material slowly gathered together to form larger and larger objects, eventually becoming what we now know as the planets. But these primordial planets looked almost nothing like what we know today. The early solar system was essentially chaos. Frequent collisions and constant friction meant that the planets were hot, very hot. This is when the planet's first oceans formed. Well, not the oceans you're thinking of. These were vast seas of molten rock. Extreme volcanic activity meant thick, steam-filled atmospheres with temperatures reaching thousands of degrees Celsius. But with enough time, these planets began to cool, eventually reaching a point where the water vapor in the atmosphere could begin to condense and fall to the ground. The water cycle began as streams and rivers carved through the landscape. This water collected in low basins and marked the solar system's first liquid water oceans. Interestingly, due to being just half the diameter of Earth, it's believed that Mars was able to cool itself more efficiently during the early days of the solar system and pooled water on its surface in a time when Earth was still a violent, boiling landscape. Earth may have actually been late to the party. So then what happened? How did Earth become this lush haven for life while Mars remained a cold, dead remnant of what once was? To understand, we have to look at these planets side by side. Here is Earth and Mars to scale. From this comparison, it becomes much clearer that Mars really is the little brother. While just half the diameter of Earth, Mars is only about 10% as massive. As I just mentioned, this provided Mars with a strong advantage in the race to develop a liquid ocean in the early days of the solar system. However, this came with a heavy pitfall. Mars was able to quickly cool down to temperate conditions, but over millions of years, this process continued, and the dense liquid metal core of the planet began to feel the effects. On our home planet, this metallic core is essential to life as we know it. At the epicenter of the planet, pressures and temperatures reach unimaginable extremes. Made mostly of liquid iron and nickel, the outer core exists in a permanent liquid state. This fluid is constantly moving around and generating electric currents through a process known as convection. This energy generated is known as the magnetic field. The magnetic field is an invisible force field that surrounds the Earth. Most importantly, it protects our planet from the harsh radiation emitted by the sun. This is why astronauts experience elevated levels of radiation when they leave Earth. They pass through the most protective layers of our magnetic field, where they become exposed to the solar winds and the other harsh conditions of outer space. When Mars was warm in the early solar system, it had a magnetic field just like Earth's. However, as the planet and its core cooled, the liquid metal slowly solidified. The process of convection slowed. eventually halting completely around 4 billion years ago, or just 600 million years after the formation of the planet. And with this, its magnetic field was gone. While Mars may not have looked much different during this transitional period, this was the beginning of the end for the red planet as it was. You see, the solar wind isn't just harmful for life, it's harmful for the planet itself. As charged particles fly towards the planet, they collide with the atmosphere. Sometimes these collisions generated enough momentum to knock atmospheric particles upward and into the vacuum of space. These particles are carried away, leaving the atmosphere slightly thinner. This process is slow but relentless. Over the course of the next billion years, the atmosphere continued to shrink. Water vapor in the atmosphere was slowly lost to space. Rain on the planet stopped. With an atmosphere too thin to support a water cycle, remaining liquid was stuck in still oceans and lakes. Nothing could stop this runaway chain of events that was set into motion. Soon enough, the planet reached a critical state. You see, when pressure drops to a certain point, liquid water begins to evaporate, regardless of temperature. Eventually, the atmosphere became so thin that liquid water could no longer remain stable on the surface. Once in the air, the vapor was exposed to the solar winds and slowly stripped from the planet, never to return. Over time, the oceans sunk lower and lower. As they dried up, the last stable bodies of water on the surface of Mars existed deep inside small craters where pressure was sufficient, until eventually, the last one vanished. Today, any remaining water is left frozen either in the polar ice caps or under the rocky surface. So, interestingly, the Martian ocean did not disappear suddenly. It was a slow, creeping process that took around 1 billion years. And that is how an ocean dies. But then why is this not happening to Earth? And could we suffer the same fate? Well, it actually is happening to Earth, just at a much slower pace. Both planets are cooling. Both are gradually losing the heat left over from their violent formation billions of years ago. The difference is that Earth began the journey as a much larger world. Deep beneath our feet, a churning ocean of liquid metal continues to generate a magnetic field. Volcanoes still erupt, tectonic plates still move. The systems that Mars lost billions of years ago are still operating today. But one day, the Earth will cool. This process is predicted to take billions of years. But luckily, or maybe unluckily, it's not something we'll have to worry about. Because long before the Earth loses its magnetic field, our home planet will meet a much different fate. In an estimated 1 to 2 billion years, the aging sun's energy output will increase to the point that Earth will become uninhabitable to life as we know it. Earth will die a hot death rather than a cold one. Two planets born from the same cloud of dust. Two worlds that may once have looked remarkably similar. Yet today, only one still carries oceans on its surface. The other serves as a reminder that even planets can die. Mars died young, and with luck, Earth will die of old age. But until then, Mars will remain a cold, barren reminder of what once was and what could be.